All right, we are on chapter 35, image formation, and we're going to start 35.1, images formed by flat mirrors. Um, let's share the PowerPoint, and here they just show a cell phone and a magnifying glass. If you have a magnifying glass, you can play with it, and you will form images, and we'll get to images formed by thin lenses. But let's just get started with the flat mirrors. We played with this with the mirror. You can see that there's a mirror here. We're looking at the cross section of it, so we're looking at it's perpendicular to the image here. This thick blue line, that's the reflecting part, and this is just like the glass that holds it. Actually, most of the time, the reflecting side is on the opposite side, so you get a double image of you get a double image reflecting over here and reflecting off the front side. But we're just going to go with what they have here. And notice the distance here, P, that's the object distance. Q, this is the image distance. So that whatever you have, the object, the rays, we use ray analysis to look at these images. The rays diverge from this point here, the object, and using the laws of reflection, they bounce off. If you recall, the incident angle is equal to the reflected angle, and so they diverge. They come off of here and hit your eye, and they appear to diverge from an image that's pointed over here. This is the virtual image. This is the object. This is the virtual image. If there is such a thing as a real image and a virtual image. The real image is formed when all light rays pass through and diverge from an image point. We'll talk about that. Like movies will create real images. This is a virtual images where most or all of the rays do not pass through the image point. So we have the object distance, and the image distance. We have here the what we call the magnification, because the triangles PQR and P prime QR, the absolute value of P equals the absolute value of Q. We're talking about that because one is actually negative of the other. And we have H is equal to H prime. So the magnification, in this case, is 1. When you have a flat mirror, the magnification is 1. The image height equals the object height. So H prime equals H. So H prime over H is 1. And we'll learn about magnification when it comes to lenses and mirrors. The magnification in that case will not be 1. Okay, we're going to talk a little bit about left-right reversal. And here it says the thumb is on the left side of both real hands and on the left side of the image. That the thumb is not on the right side of the image indicates that there is no left to right reversal. We discussed this in class, the fact that the left to right reversal is really a perception on our part. If I'm looking at myself in the mirror, if I raise my right hand, it appears that the person that I'm looking at, my reflection, he's raising his left hand. But if you think about it, whatever is on the right is still on the right. It's just a perception that this image that I'm seeing, the person that I'm seeing, appears to be raising his left hand. So it's more of a perception problem than there is no real right-left reversal. If there were a true reversal, then it should reverse top to bottom, and it doesn't. So the left-right reversal that we all think about is really a perceived reversal. And there is no reversal. Whatever's on the right is on the right in the mirror image, whichever's on the left is on the left in the mirror image. So it's more of a perception problem. Okay, you were standing approximately 2 meters away from a mirror. The mirror has water spots on its surface. True or false? Is it possible for you, um, well, it's not a question, it's a statement, and you answer true or false. It is possible for you to see the water spots and your image both in focus at the same time. Um, well, let's. You can do an experiment. You can like right now that wall is, or if I look at the seam up at the ceiling, if I can either look at the ceiling or I can look at I'm holding my pen. I can look at the ceiling or I'm holding my pen. They both, if I look at the pen, I get a double image of the ceiling. If I look at the ceiling, I get a double image of the pen. So the answer is false. You cannot look at both images in focus. You're going to get a double image of one or the other. The water spots are 2 meters away from you, and the image that you're looking is 4 meters away. So there's no way to focus your eyes on both at the same time. If you focus on the water spots, you're gonna see a double image of you. If you focus on you, you're gonna get double image of the spots. So the answer is false, and that ends our first images formed by flat mirrors. From there, we're gonna go to 35.2, images formed by spherical mirrors.